A block of mass 24 kg is on a rough horizontal table. A force F is applied on the 24 kg block at an angle of 35 degrees to the horizontal. The 24 kg block experiences a force of friction of 7 newtons as it moves. The block of mass 12 kg, which hangs vertically as shown in the diagram below. Now, the 24 kg block moves to the left at constant velocity. Please guys, note that part that talks about a constant velocity. A constant velocity means that our acceleration is equal to 0. So whenever you say Fnet equal to ma, when you simplify your problems, your acceleration will be 0. Therefore, our Fnet will be equal to 0. Or our resultant force will be equal to 0. Welcome guys, I hope you're all doing so well. On today's lesson, we're going to do previous question papers. This one, I took it from Metro Central Education District, National Senior Certificate, September 2021, paper 1 in the Western Cape province. Let us do question 2 in preparation for our paper 1 physics. Let us just start. We are going to talk about all that has to do with forces. Yeah. Question 2, paper. I get you guys who have already read the statement. Now you're answering questions 2.1. For 2.1, the question says that state the Newton's second law of motion in weights. It's very important, guys, to state the Newton's second law as per the guideline says. So it's very important to apply what is on a guideline more than what is on your mind, or what do you think of Newton's second law. We just need to collect maximum marks. That's our aim. Now, here's the definition of Newton's second law. When a net force acts on an object. When a net force acts on an object, the object will accelerate in the direction of the force. In the direction of the force. I'm getting, guys, in the direction of the force, and dot the acceleration is directly proportional to the what? To the force, to the force, and inversely proportional to the what? To the mass of the object. To the mass of the object. So guys, it's very important for you to go into the examination knowing all the 3 Newton's laws. They can ask you any of the 3. It will depend on the marker, but usually they ask about Newton's second law. But just be familiar with all the Newton's laws of motion. So guys, here's the definition. Here's how we state the Newton's laws in motion. This is the basic definition. This is the one that is on the guideline. Please know it and understand it properly. Then let us go to the next question, 2.2. Let us answer 2.2. Now, 2.2 says, what is the resultant force acting on the system? What is the resultant force acting on this system? What is the resultant force, guys, acting on the system? Now, resultant force, remember, it is all the net force acting on the object. Which means resultant force is our Fnet, basically. All net force acting on it is a net force, and it's Fnet. When they talk about resultant force, they're talking about Fnet. When they talk about the resultant force, they're literally talking about the Fnet, and Fnet here is equals to 0. Why? Because of what? They said that the 24 kg block moves to the left at constant velocity. Once they say okay, the object is moving at constant velocity, this means that your acceleration is equals to 0 meters per second squared. Hence we've got 0 on our side. Because of what? Because, for an example, Fnet is equals to ma. Where I see a, I put in my 0. So I'm going to have m times 0. Therefore, m times 0 is equals to 0. Hence, my Fnet is equals to 0. That's how, that is the resultant force acting on the system. Is equals to 0. I hope you understand. So you need to be familiar. When they say you must find any force acting on an object, our Fnet should always be equal to 0 going forward. Let's go to 2.3. We've got 2.3. 2.3 says equal to draw a fully labeled free body diagram for all the forces, or for all the horizontal forces acting on the 24 kg block for 3 marks. Which means I'm going to draw the horizontal forces, which means the free body diagram for all the horizontal forces acting. Free body diagram. And they said to you, the object is moving to the left. That means our F applied is to the left. F applied. And here, now remember, friction is involved. And here, this frictional force is there. That means frictional force, it opposes the motion. So we're to the right. And here, this is our frictional force. And we have a tension. Remember, tension force again. And here, our rope is our tension. Therefore, tension is going to the right. And here, remember, we have another box here, which is 12 kg. That means our tension is going to the right, not to the left. Yes, guys. So our tension is going to the right, not to the left. So here's our tension force. F tension. Just right tension. For 3 marks, they will mark you. You have drawn this. You have drawn for FT. You have drawn for frictional force. Now 2.5. 2.4. 2.4. They say calculate the tension in the rope. Calculate the tension in the rope. Find the tension in the rope. So guys, how are you gonna find the tension in the rope? Remember, tension is part of Fnet. That means tension, it forms the net force, part of the net force. Therefore, hence Fnet is equals to ma. But you already know that our acceleration is 0. Therefore, total Fnet is equals to 0. Then now, which box are we going to use to find our tension force? Remember, tension force is present on our 24 kg block. We don't have the value of the force applied. Hence, we cannot use this block, 24 kg block, to find our tension force. But you can literally use the 12 kg block because we've got our weight and our tension force. Let me just draw the free body diagram of a 12 kg block. Free body diagram of a 12 kg block. If I draw the free body diagram of a 12 kg block, we've got our tension force and our weight. Therefore, these two forces, they're going to act on our 12 kg block, and I'm going to use this formula to find, or I'm going to use these two forces to find my F tension for 2.4. I hope you can literally hear me, guys. Now, so therefore I'm going to have my tension force minus my weight is equal to 0. Then tension is minus, what is the value of weight? Weight is equal to mg. So mg is going to be 12 multiplied by 9.8. 12 is our mass number of the 12 kg block, and 9.8 is our gravitational force, and is equals to 0. So on your calculator, you're going to say 12 multiplied by 9.8. Let me just let me just set up 12 multiplied by 9.8. Keep guy. Give 1 so go back tension minus 117,6 is equals to 0. Therefore I'm going to transpose this 117,6 to the right, and therefore my tension is equals to 117,6 newtons. This is the value of our tension on the block. I hope we can literally hear me. That's our value of our tension. So our tension is equals to 117,6 newtons. So I hope you can literally hear me, guys. That's how you calculate the tension force there. Now 2.5 it says that calculate the magnitude of the force. Calculate the magnitude of the force F. Now what the magnitude of this force? Remember we said that if what the magnitude of any force acting on the block, you need to use Fnet, and we know that Fnet is equals to 0. Now what are forces acting on that? Remember, where do we find the force or the force applied between these two blocks? We find force applied on the 24 kg block. Therefore, let me just start by finding or writing all the forces acting on the 24 kg block. Remember, we have just drawn our free body diagram of the 24 kg block. So please, from that free body diagram, I'm going to take what is needed there. So we know that Fnet, not Fnet, force applied, force applied, guys, force applied minus, remember, it acts opposite, minus tension force plus, what's that one? It's tension force and frictional force is equals to 0. Remember, we just found the value of our tension force, and the sign in the previous question of 2.4, the sign of our tension was positive there. Therefore, the sign of our tension on this in this case is going to be negative, irrespective. So now remember, guys, for force applied, it acts at an angle. And remember, our block is horizontal. Therefore, we're only going to apply the component of cos theta. So we're going to apply cos theta there, the ratio of cos theta. Remember, because of what? The block is acting perpendicular to the horizontal. So we're going to use cos theta there. So now, if you want to find the value of F here, and it acts at 35 degrees angle, so we're going to say F cos theta minus our tension minus our frictional force and equal to 0. Remember, this negative is going to multiply our tension force. This negative again is going to multiply our frictional force. So we're going to have negative tension minus frictional force. So use this cos theta all the time. When the block is acting at an angle, if it's on a horizontal surface, you always use cos theta. Even if they can give you the value of our force applied, if they can say the value of our force applied is 10 newtons, so you're just gonna write 10 cos theta here. But right now we need to find the value of F. We need to use cos theta all the time, if and only if this block acts at an angle. If there's no angle anymore, you don't put in this cos theta, you just write F as it is. But if you have an angle on the block acting on a horizontal surface, you put an angle. They will show you on the diagram this force is at an angle to the horizontal. Yes. So you're gonna have force cos 35 degrees minus, we got our tension 117,6 minus, what is our frictional force? 7 newtons is equals to 0 force. So we're gonna say, so just leave this out, just leave this one out for now, leave it out for now and focus on adding the constants. So what are our constants? Is negative 117,6 minus 7. Keep guy. Force cos 35 degrees minus 1 2 4,6 is equals to 0. So I'm going to transpose this negative 1, negative 1 2 4,6 to the right. So I'm going to force cos 35 is equals to 1 2 4,6. So I'm going to divide both sides by cos 35. Cos 35 and cos 35. Then this cos 35 will divide this one and force I want you guys. Okay, 124,6 divided by cos 35. Our answer is 152,12 newtons. This is our value of our force on this block. How do you mark it? Remember, you've put in 0 on our right. You've written the forces there. You mark it with Amona, and the final answer obviously. And you have divided both sides by this cos theta. You have written all forces acting on the object, including the angle there. Yeah, I think that's how they're gonna mark it in the examination for 5 marks. So guys, the last question, it says go to the last question, which is 2.6. 2.6 is our last question. 2.6. It says go to force F is now removed. That means we remove force F. This one, we remove it. Force F is now removed. Does the magnitude of the normal force increases, decreases, or remain the same? If we remove this force, remember if F will our normal force increase, decrease, or remain the same? The value for normal force. Remember, this force here, if you remove this force applied here, remember it's our normal force is just right up there, our normal force. So if you remove this force, because it might form part of the normal force, if you remove this force here, you remove it, it forms part of the normal of our normal force. Therefore, the value of our normal force will decrease. Due to the fact that if it acts at an angle there, it will have an effect on the value of our normal force. So if you remove it, it's going to decrease. I hope you have joined the lesson. Please join me in the next session for part 2 of a series of Newton's laws. We're going to do projectile motion. We're going to do again work, energy, and power, electricity, and electrostatics in preparation for, and momentum in preparation for your paper 1 physics. Thank you very much, guys. Enjoy the day.